National 4-5 waves, diffraction. In this section, we are going to be looking at defining diffraction, diffraction around objects, diffraction through gaps, and some practical context of diffraction. Our learning outcomes: I can describe what is meant by diffraction, compare short wave and long wave diffraction, and use my knowledge of diffraction to explain differences in radio and TV reception. On the next slide, there's a short introduction to diffraction.
Diffraction. One property of all waves is diffraction. This is where waves spread out at the edges or diffract when they pass through a gap or go past an object. Let's look at some water waves from above. We can see the diffraction happening here. If we set the gap much bigger than the wavelength, we don't get much diffraction, just a bit of a spreading out at the edge. But as we decrease the size of the gap, we get much better diffraction until the gap size equals the wavelength, when we get maximum diffraction. It should also be obvious that we could have increased the size of the wavelength, leaving the gap size the same, and that would also have improved diffraction. The main thing is we get the gap size to equal the wavelength. So this is great, but is there a practical use for this? Well, there is. If you lived near a big hill, you might have problems getting TV or radio reception, as the waves would be blocked by the hill. But because of diffraction, the waves spread out when they pass the hill and can be received by your aerial. However, the really short wavelength signals will still miss, but you'll get the longer wavelength ones. So in summary, diffraction is where waves spread out at the edges when they pass through a gap or go past an object. And diffraction happens best when the wavelength equals the size of the gap.
Okay, so all waves will bend around objects placed in their way. It's that bending effect that we call diffraction. If you have a look at the two animations here, on the left, diffraction phenomenon 1 shows the waves bending around an object. They bend on both sides, and that bending we can see is a curve inwards towards the center of the object. In the second animation, diffraction phenomenon 2, we see waves diffracting through a small gap within the medium. The size of the gap is going to affect how much diffraction takes place. Diffraction around objects. We find that longer wavelengths, for example radio waves, will diffract more than shorter wavelengths, e.g. microwaves. In the diagram we can see a long wavelength radio wave passing a hill, diffracting, and being picked up by the aerial on the building on the right hand side. However, shorter wavelengths, for example TV waves or microwaves, don't diffract enough. There's not enough bending of the waves towards the aerial, and so the aerial can't pick up. This is why, if you are in hilly areas, you may well have good radio reception, but you might not have very good mobile reception. Diffraction through gaps. When a wave diffracts through a gap, the amount of diffraction that takes place depends on the wavelength of the wave, the size of the gap, and how these two measurements relate to each other. With a larger gap, there's much less diffraction, and we can see this by the waves not bending as much as through the small gap on the right hand side. Where the gap size is equal to the wavelength or smaller, we have the most diffraction. So what are the practical contexts of this? Well, diffraction is why we can hear sound from objects around a corner but cannot see them. In the diagram, the student is walking on one corner of the wall and the radio is around that corner. The student can hear the radio playing because, as we can see in the diagram on the right, the radio waves are diffracting around the edge of the corner. However, the student is unable to see the radio because light waves have a much higher frequency and therefore a much shorter wavelength and don't diffract as much. So sound waves have a much longer wavelength than light waves, or indeed any other part of the electromagnetic spectrum, and so experience more diffraction.